real numbers are divided into two big groups. Irrationals and rationals. Expressed with the Q because it's a quotient, because why are rationals expressed with the Q? Anybody have any idea?
Because it's
what are rationals? What are rational numbers?
1, 2, 3.
Also, but
1 for
real numbers.
2.
Rationals are numbers that can be expressed as a fraction.
Okay.
Hence the Q for quotient, because a fraction is an implied division, remember? So these are ratios, rational ratio, fractions. So rationals are any number that you can express as a fraction. Irrationals cannot be expressed as a fraction, hence the name irrational. Okay? Irrationals are
Pi,
phi, e. I is imaginary. No, I is outside of this. It's not part of the real number.
What's
hence the name
the
many.
difference between the symbol of rationals and the other one?
This one and that one?
Yeah.
This one's crossed out.
No. This one.
Whereas this one is like this. Okay? This was 5. This is e pi. All the square roots of prime numbers are here also. Square roots of prime numbers are all irrationals. And how do you know they're rational or irrational? Well, if they have decimals that go on forever and have absolutely no pattern at all, they are irrational. If they are rational, you also have repeating decimals, but they are repeating. Rationals. 0.33333. This one you can write like this.
What about
Isn't that a decimal number?
0.432?
This is a repeating decimal, repeated because it's the same number repeated. And this one you can turn into a fraction. What fraction is this? It's 1/3. Remember when you were dividing when you were little and you would say, Miss, can I just stop here because it's always going to be 3? And then she would tell you, yeah, you can stop 2 decimals. It's this case. Or this one. Which you can write like this.
Then what is it over?
What number is this one?
1 over 2?
1 over.
That'll be 1
1
over
over 11.
1 over 10.
It's 1
1 10.
It's 1/3 of this one. And what's 1/3 of 1/3?
1 9.
1.
Very good. 1/9. This is 1/9. Okay? And guess what? Just because I like playing with your minds, what would this one be?
0.67.
No, 0.6 and the thing on top.
Devil.
And that what is that?
0.67.
It's 2/3. If this is 1/3, this is 2/3, right?
Martin, you're so diabolical,
Okay.
man.
No, that number.
Okay, it's not the number of the beast because it's got more than 3 6s. Okay?
What about 0.04323232?
Okay. So, is it clear what this little line on top means?
Yeah.
What does it mean?
That it repeats
It repeats. But so what? But they're asking me. I can't turn this around. Why not?
Just let it. We can't have it. No, that's gonna die.
It died. Already.
It died.
Okay. What would this be?
No clue.
12,
1 2 1 2 1 2 1 2 1 2
Oh, R2D2, R2D2.
And this one?
That one would be
Oh.
36.
36, 13,
36, 1, 2,
13,
13,
13, 13.
Okay. So it's clear what the line means.
Yeah. Really clear.
All of these numbers, when they are repeated like this, they're called periodicals.
Whoa.
Why periodicals?
Because they go forever.
No, because they repeat every certain period. hence the name period for girls. It repeats every 28 months. That's why it's called a period.
What?
Because it's periodical.
That's
Every time. Periodical. It's a periodical. It repeats every. Even if it's a weekly magazine, it's also a periodical. Because it repeats every certain period of time, okay? In this case, it's every certain period of numbers. You're going to be asking me this later, and it's on video. It's not just me.
What about the periodic table?
Because it follows a certain pattern in the periodic table. That's why it's called a periodic table. Okay, so is it clear what a periodical is?
Yeah.
Now, it turns out that all periodicals are rational. The reason why pi isn't rational is because it's not a periodical. The numbers of pi never, ever, ever repeat. There's no pattern to pi. There's no pattern to e. There's no pattern to 5.
What is it?
There's no pattern to square root of 2.
Or 3 or 7.
They just go on forever, like they do, but there's no pattern. Okay? These have patterns. So, this lesson is all about teaching you how to turn periodicals into fractions. Okay? So this whole explanation is to get you started on how to change periodicals into fractions.
Times
So
10
how do we
over
do
8.
that?
Over 10 over 8.
Let's say that do you know how to change normal decimals into fractions?
Yes.
Yeah?
Yeah.
So if you have 0.000314, what do you do?
Ah, 214 over 10, 100,000.
Over 1.
I don't know how many zeros this is.
Well, this is 10.
10, 100,000, 100,000? No. 10, 100,000,
100,000.
10,000,
4, 5,
100,000. I don't know.
What?
Yeah, there you go.
That's what it is,
Yeah.
right? Okay?
Million.
Yeah. Because there's 6 positions, so it's 0. Okay?
No.
Got it?
That's
And that's how you turn it. Of course, you can simplify this. You divide by 2 and you reduce, but that's how you turn it. Okay. But what happens when you have something like this? 0.01623 periodical. What happens is you have 0.016232323
And so on.
and so on. Okay? So this technique, what it does is you are going to try to take away the 23232323. How do you do that? First of all, you identify how many numbers are being repeated. And it's 2. Therefore, you are going to multiply times 100. Why 100? Because it has 2 zeros. Okay? So that means that you are going to start out with 100 and
X.
100 or x, doesn't matter. You want x?
Yeah.
100x. 100x would be this number multiplied by 100. And that number multiplied by 100
1.623
would be 1, 2, right?
Yeah.
So this would be 1.6232323 and so on.
Can we put the
Now it's subtracted by the original.
So you did understand it. Why are we doing this?
Miss, can we put the periodic thing instead
Minus
of
x, which would be
0.016.
Why minus x?
because you're trying to you'll see why. Hold on. That's the technique. Because that way you get rid of the following. 0, 1, 6, 2, 3, 2, 3, and so on. Now notice something that happens here. When you do it subtracting the x, you are going to align these. Look. And that means that when you subtract them, they go away. That's why it's got to be subtracted. Because if you add them, you're going to have 46, 46, 46. And that doesn't get you anywhere. So, but if you subtract them, you get rid of them. And what you get...
Divide by
99x.
But wait a minute. You've got 99x.
Equals 1.607.
How much?
607.
607?
no.
Yes.
Yeah, right? Yeah.
607. Okay, he memorized.
I don't even know.
607. So now, what are you trying to find? You're trying to find x.
So divided by 99?
The
And
answer
then,
is
and then multiply the numerator and the
But hold
denominator
on.
by
But
1.
we can't have decimals because we're trying to look for fractions, right? So what do we have to multiply by?
By 100.
By 1,000
Oh,
because I've got 3
Oh
decimals.
yeah, 3 zeros.
So I'm going to change this into 1607 divided by 99000.
That's the answer.
Okay?
Oh.
In this case, it ends in a 7, so you can't reduce. But sometimes you can. Is it clear what we did?
Do we have to reduce?
Always.
Okay.
If you can.
Let's say that this had been a 5 here, and I've got 3.
Then you
Decimals.
multiply by 1,000.
Then I would multiply by 1,000, and I would do exactly the same thing.
And if it's just 2, then
And then
it's
it
just
wouldn't be divided by 99, it would be divided by 999. Is that clear?
Yes.
Do you want me to do one like that, or is it okay?
It's
okay.
Sure. It's really short.